Hi, welcome to my video on review 1 of maximum minimum word problems. But this review is on the videos 1 to 4, and again it's just one question with a maximum word problem. Here we go. A cone is inscribed in a sphere. The radius of the sphere is 6 inches. Find the maximum volume of the cone that's inscribed in a sphere. Well, a sphere is a ball shape like this, and if you can imagine, you're looking at a ball and you have a sphere inscribed in it, which means that the base of the a cone is inscribed in the sphere. That means the base of the cone is going around like this. So let's take this as the center of the sphere, the center of the ball, and we have and I try to draw halfway here like this. So that's going right around the outer edge of the sphere, and the top of the cone is here, and this is, so imagine that you have a cone like an ice cream inside of the sphere, and this is the center of the sphere. So what happens, because that's the center of the sphere, any point at the center to any point on the edge or the surface of the sphere is 6 inches. So from the center of the sphere to this edge is 6. From the center of the sphere to here is 6. So that's a 6 and a 6, and they are at right angles. So the volume of the cone that's inscribed inside, the volume of the cone is 1/3 the volume of a cylinder, which is pi r squared h. So that's 1/3 pi. The radius is 6 and the height is 6. So we have 1/3 pi. 6 squared is 36 times 6. So 1/3 times 6 is 2. So we have roughly 72 pi, and that's a volume cubic inches. Now, let's draw another one. This time I want, that's if it was right in the middle, coming right on through. That's like this cone would be in a half a sphere. But what about if I want to draw one more now, very similar to that again. But what about if the height of the cone moves downward? So here's the center of the sphere still, but instead of being here, let's move down right in here. So here's the right straight down from the top. Is this going down right to this here? So right here and here, I'll draw this, the base of the cone going around here like this, and the dotted lines are inside, but you can't see that edge. So there's your cone on the inside. So what I did is that this is the center, so this is a 6. So I went down from here to here and created this as a 3. And that means it's 3 down here. So there's 12 altogether from the inside the sphere. So if you went through the middle of the sphere with a diameter, you will have a 12. So this is the middle 6, and so this is the middle again. So here's a cone that has the center at 9 height, and the distance from here over, so that's the radius of this new cone now. This height is 9, but what happens is that this is still 6, because this is the distance from the center of the cone out to the edge, from the center of the sphere out to the edge of the sphere. So we have a right triangle. You see the right, I'm going to put an O here, and put an A here, and put a B here. So what we have is a right triangle. I'll label it this way: O, A, B, with a right angle. So this is 3. This is the diameter of the or the radius of the sphere, which is 6. So this is the radius of the cone. So what we have is c squared is a squared plus b squared, and we have 6 squared is 3 squared plus r squared. So that's 36, 9 plus r squared. So r squared is 36 minus 9 is 27. So r is plus or minus the square root of 27. So r is plus or minus 3 root 3, but we can't take the negative. So the volume of the cone, so yes, the volume of the cone is 1/3 pi r squared h, and so that's 1/3 pi. So the radius is 3 root 3 being squared times the height, which I made is 9. So that's 1/3, and 3 root 3 squared is the 27 back, because if the square root of 27 is 3 root 3, then 3 root 3 squared back should give it 27. So 3 into 9 goes 3, so that gives you 81 pi cubic inches. So I did this just to show you what I'm going to do next. It will make sense. So here we are. Let's turn the page and let's get to the question. The question reads, a cone is inscribed, so now I'm going to draw another one. So here's a sphere, and I'm going to inscribe, this is the center of the sphere, I'm going to inscribe just anywhere, it don't make any difference. So I'm going to make it like I did before. This is dotted over to here, and so this is coming down through right to the middle here. So what we have is, this is 6, and this is the center of the sphere. So when I come to this edge here, that's a 6, and what I have here is the radius of the cone, r, and I'm going to put, now I don't know what this height is, but I'm going to call this height x. So the distance from the center, distance from the center of the sphere to the center of this circle, which is going around the sphere, is right here. So now I have a right triangle, and I have, let's call that O, let's call that A, and let's call that B again. So I have an O, A, B. So what we have is a 6 and an X and an R. So C squared is A squared plus B squared. So that's 6 squared is X squared plus R squared. So that's 36 is X squared plus R squared. So what I want is in terms of the radius, because I want the maximum volume of the cone, so I need the radius and the height. The height of the cone is from here to here, so the height of the cone is x plus 6. So that means I need the radius expressed in terms of x. So the radius is in terms of x. So let's solve this for r squared is 36 minus x squared. So that means r is plus or minus the square root of 36 minus x squared. So what's the height of the cone? So the height of the cone is from here to here, so the height of the cone is x plus 6. So the volume of the cone is 1/3 of a cylinder, and a cylinder is a circle, pi r squared times the height. So the volume of the cone is 1/3 pi, and the radius is the square root of 36 minus x squared. So there's the radius right here. So I'm going to put a square on that, times the height, which is x plus 6. So that's 1/3 pi. And when I square this out, I get 36 minus x squared, and times x plus 6. And now I have a 1/3 pi, and I'm going to multiply this out. So 36 times x, 36x, 36 times 6 is a negative, or sorry, 36 times 6 is a positive 216. Negative x squared times x is negative x cubed, and negative x times 6, negative x squared times 6 is negative 6x squared. So that gives us 1/3 pi. I put this in descending order, so I got a negative x cubed minus 6x squared plus 36x plus 216. Now, you said I didn't want to multiply this in because if I want to get the maximum volume, that means I have to do the derivative. So I have to do d dx on the volume. So that means I got to do d dx on all of this. So just take time to write this down. Be careful to write it down correctly. I have a tendency to make a mistake at times, as you've seen me do. So that's dv dx, that's the derivative of the volume in terms of x. So this is a constant, so I'll leave the 1/3 pi there. That's a constant. Derivative of a constant is, leave that outside. Now I could have that in here, but it's the same, so I'll leave it there. So now I'm going to do the derivative of a negative x cubed, which is a negative 3x squared. Negative 6 times 2 is negative 12x. 36 is linear. Derivative of a constant is 0. So I'll put the 0 in, but I didn't have to. So d dv dx is, so if we make d dvx equal to 0, so that makes I'm making 1/3 pi times negative 3x squared minus 12x minus 36 equal to 0. So this is a constant, so I can divide by this constant, so that means that I have negative 3x squared minus 12x plus 36 is equal to 0, because if you divide by 1/3 pi on each side, that cancels out to give you 1, that gives you the 0 right here. I got a negative 3, so I can remove the negative 3, divide by negative 3, because negative 3 is a factor. So negative 3 will divide into all of these. X, oops, my mistake, x squared plus 4x minus 12 equals 0. And I divided everything by negative 3. I got a quadratic, so I'll factor it. And x squared is x and x. Factors of 12 to give you 4 is 6 and 2. Remember, 12 is 12 times 1. 6 times 2 or 3 times 4. But the factors of 12 to give you 4, 6, and 2. Product is negative, so one of these is plus and one is minus. Because the sum is positive, so the larger one is positive, smaller one is minus. X plus 6 equals 0. X minus 2 equals 0. X is negative 6. X is 2. So we have the rate, x can't be negative, so throw that away. And now we'll take the 2 and plug into whatever expression you want. You put it into, let's see which one you want to put it into. Put it into this one right here. If you put it into here, the same thing. Don't make any difference where you put it in. You can put it in here. So let's say the volume of the cone is, let's put it into, I could put it into this one, but I'll have, it's easier to probably put it into here. 1/3 pi. We have 36 minus 2 squared, and we have 2 plus 6. So I'm taking the 2, I'm putting it right here and right here. And I take my time and work this out. So we got the pi. So let's work out the inside of this. So inside of here I got a 4, and 36 minus 4 is 32, and we have 2 plus 6 is 8, and 3 is not a factor, so if you multiply 32 by 8 you get a 256 over 3 pi, and that's in inches, CU, cubic inches. But I can spell right. Sometimes my spelling goes wacky wiggly. So notice I, again, let x be the distance from the center to here, and it's flowed easy. And I wrote the volume in terms of x, the derivative in terms of x, and let the derivative equal to 0 to get the values of x that will give you the maximum, and then sub them back in. And we have 11 points. And if you drew the diagram correctly, take a mark. If you come up with the height, you got a mark. If you come up with this expression, you got a mark. If you knew the volume of the cone is 1/3 pi r squared h, if you come up with this expression, you get a mark. If you did the derivative correctly, down to here, everything was perfect. So you did here. If you simplified and did the derivative and you let it equal to 0 and you solved it out and got a -6 and 2, and you sub your 2 in, you got a mark. So 11 marks altogether roughly, and that fulfills the question here. And I wanted to do this one with the cone being inscribed in the sphere to let you know what's happening in case you didn't see it before. And this brings us to the end of this video, which is the review 1 on videos 1 to 4. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.